Ray, why don't we start with you?
Sure. Well, welcome, everyone. I'm Ray LaChance. Our company, Zenfi Networks, is a New York-based network provider that was started about 2 years ago with a mission to help solve the densification problem in a dense urban environment like New York. And our focus is providing fiber connectivity to antenna locations, any and everywhere. We have a phrase we say internally, any pair, anywhere. Our goal is to provide the fiber footprint supporting the mobile network ecosystem in a way that hasn't been done before, and help solve the access problem that we foresee with existing fiber infrastructure throughout the city. So, simply put, we're part of the ecosystem, and we provide underlying fiber infrastructure.
Thank you, Ray. Thank you for the introduction. Dr. Femi, you want to tell us a little bit about yourself and what you do at Fujitsu?
Good afternoon, everyone. I'm Femi Adeyemi, Solutions Architect at Fujitsu. Fujitsu primarily is a company that is very well versed in RAN, as well as all the other supporting infrastructure around RAN. So if you're talking about densification with small cells, with remote radio heads, centralized baseband units, the transport that connects them, whether that's on the fronthaul side or on the backhaul side, and also with partners with virtualization of the core, Fujitsu play in those spaces. So we are very, very active in those areas, both from product, technology, as well as solutions. I'm happy to be here.
Thank you. Thank you. Ken, go ahead.
Hi, Ken Sandfeld, Solid. Thank you for having us here today. Appreciate it. Solid is a global manufacturer of coverage enhancement and optical network products. We're part of this panel here today mostly due to our experience in deploying CRAN networks in places like Asia, where we have tens of thousands of CRAN nodes deployed on our optical networks and tens of thousands of indoor and outdoor radio nodes deployed for 3G and 4G networks. We have a complete line of indoor and outdoor coverage enhancement solutions. We manufacture all of our own amplifiers and really set up for the next generation of densification requirements out there in the requirements in the marketplace. So thank you for having me.
Thank you, Ken. Lance?
Lance Kraft, I'm the Vice President of Sales for Dolly Wireless. Dolly, established in 2006, we operate in more than 30 countries. We have sales operations in North and South America as well as EMEA and APAC. Dolly is an all-digital IP packet platform. We support both commercial and public safety deployments, neutral host and venue host deployments and solutions. We easily integrate unlicensed spectrum such as Wi-Fi into our solution. And again, Dolly is an architecture that assigns IP packets to the remotes. We route these packets over a digital platform, fully software configurable, allowing for easy migration for the carriers to RAN virtualization. We're proud to be here. We hope that you're having a good time at CTIA, and Vegas hasn't been too hard on you in the pocketbook. So.
All right. So thank you, gentlemen. So as a summary, it looks like we have 3 equipment vendors, right? Dolly makes equipment. Ken and Solid makes DAS equipment. Fujitsu is an equipment vendor, but Zenfi is a fiber operator, right? So we're going to get a perspective from both sides, the fiber operator side as well as various equipment vendor side, about how the radio access network is evolving. And when we talk about virtualization strategies and virtualization of the RAN, what we normally mean is the separation of the radio from the baseband unit of a base station, where the radio is placed much closer to the antenna and closer to the user, and the baseband is pooled in a room where it's shared at some point or virtualized, ideally run on multi-processor, multi-core processors, where the capacity of base stations, instances of base station, is directed to the radios that need it most. So the benefits that users and service provider will get out of virtualization is efficient networks, more efficient networks, networks that dynamically adapt to provide capacity where the users are, and they share resources in such a way that instead of building 20 base stations in one area, you build 20 radios, but you add the capacity of n number of base stations up to 20 over time, so you can save money and save cost and deliver efficient throughput. So with this in mind, I'm going to give the microphone to Femi, to Dr. Femi from Fujitsu, and having walk us through the key phases that mobile operators are moving towards virtualization.
Thank you very much for that question. The way most operators are looking at this issue is that they don't want to disrupt the network that they have today. And so one of the key things to do is how do you now build CRAN, centralized RAN or CloudRan, overlay that on top of what you currently have today without shaking the resources, without messing up your network, so that your users are still able to experience the quality of service, quality of experience that they have today. In our experience, what we've been doing is we're starting from the transport side. Very, very active with the fronthaul aspect, where we're defining for operators, whether it's a ring network or point-to-point connectivity on the transport side, build that transport aspect of their fronthaul to be very solid. And then when they start layering on remote radio heads in the different areas where they need to add more support or use small cells, it's much, much easier for them to do that. So the different phases are we're starting from the transport side, then we go towards the core to introduce centralized basebands, and then now you can start densifying the different places where you need more coverage, more capacity with remote radio heads, whether that is a small, in cases of indoor, very, very small power, or very high power, when you're talking about 40, 50 watts. That's the trend that we're seeing in the industry. And then later on, we begin to do more virtualization towards the core. So transport, then the access, and then you move into the core.
Thank you, Femi. My next question is to Lance, Lance from Dolly Wireless. How do mobile operators, Lance, overcome today's exponential growth challenges in a way that they make a deployment that allows them to migrate to the virtualized RAN while meeting today's demands?
It's a very good question. Actually, it's a great question. And we believe we have a system architecture that meets that migration path. The one thing you have to keep in mind is, and Femi talked about this a bit, is protecting the assets that are in the network today while migrating to the platforms of the future. Dolly, obviously, in our point of interface, we have the ability to protect the assets that are in place today. We have what we call an open API, which allows for any BBU to be plugged into the network and transported across the fiber out to any remotes in the architecture. So the key to all of this in managing the growth is also not just managing the growth, but maximizing the throughput while minimizing the noise in the system. What does that actually mean? When you have higher throughput, it equals more capacity, right? So that's what we believe we do a very good job of with our current architecture. Now, as we migrate to RAN virtualization, we believe that those systems are going to need to be all digital. We believe that when you talk about CRAN, it means a heck of a lot of bandwidth in order to deliver the content required to these remotes in the network. Our remotes that we sell today are able to be re-imaged as they migrate to the CRAN platform or they go to data centers with large amounts of contents to be delivered. Our remotes, because of the FPGA architecture in our remotes, we can re-image that FPGA and we can actually take 100 gig in. Now, will all these remotes require 100 gig in? Most likely not, but to get from the data center out to the fiber network most likely is going to be a very large pipe to get there, 100 gig. Again, it's about delivering content to the end user on demand anywhere in the network. So as we see these systems, DAS systems designed today that have their own host in the same building, that will basically go away, and it will come, via fiber. We believe fiber is ultimately the only way to do it. So we believe we have a good platform, again, to get to the migration from today to the future.
Thank you, Lance. So, Ray, since Lance is emphasizing the need for fiber, how do you think this approach helps operators overcome the connectivity challenge? As a fiber provider, you provide that connectivity. So this separation of the radio from the baseband and then the digitization of all that signals in between needs a lot of fiber. Is it dark fiber? And how much fiber? Does it have to be point-to-point? What are your views on the fiber challenges?
Sure. So, one thing I want to back up and comment on is the evolution as we move from today's macro site, small cell, and DAS network environment towards this CloudRan or virtualized RAN environment. There's some real interesting synergies with what has been built in the past from a network perspective to support outdoor DAS builds. And if you look at the way outdoor DAS has been built, there's a co-location facility that houses centralized base stations that reach out and touch DAS remotes, amplifiers out on poles or wherever, and there's a fiber span in between. And typically, in the past, most of them we've done have been analog, and now they're moving towards digital. That same exact infrastructure, that centralized base station infrastructure, is a core component of the network that we believe will last for quite some time to come as the network becomes the cloud model or virtualized model. The fiber is one of the underlying pieces of the ecosystem that will be there for the long term. And they've been traditionally built as point-to-point networks. There's a remote with a single or multiple fibers that connect it back to the base station environment. That could easily be a wavelength, and it is wavelengths over fiber today. And ultimately, there's talk of switch networks or optical, moving this digital radio over fiber protocol over optical transport networks, or we've even discussed IP and Ethernet connectivity to connect the remote radio head back to the BBU. So we think as time evolves, the one fundamental piece that's going to remain are these neighborhood co-location facilities, reaching out with fronthaul fiber out to the remote radio head, the antenna and the radio and the filtering piece, and creating that fronthaul connectivity, and ultimately a series of neighborhood co-location facilities that are meshed together back to centralized command and control. So the fiber infrastructure is evolving, and I think, and again, when you look back 10 years ago, it's evolving out of what outdoor DAS looked like, and that same infrastructure is could be repurposed for CloudRan eventually.
So far we spoke about RAN virtualization, where we separated the BBU from the RRU, the baseband unit from the radio unit, and we put fiber in between. My question is for Ken from Solid. Does this partitioning simplify or complicate the situation where we're not dealing with one operator, but we're dealing with 4 operators where each one of them have 1, 2, or 3 different networks that they want to virtualize. So now we have radios that do multiple bands. How does this complicate or simplify when the virtualization has to apply in a neutral host environment with multi-service providers, such as DAS, where you do every day?
Thanks, Hank. So first of all, I'd like to point out that the BBU RRH concept came from macro networks. A long time ago, the goal was to put an amplifier on the top of the tower and run fiber. Why? Because coax cables are really big, really expensive, and they're really hard to pull up a 35 to 100 to 150 foot pole. So that's really how they were established quite some time ago to solve that particular dilemma in the marketplace. Since then, it's evolved into, of course, the fronthaul architectures where you're able to centralize your radio baseband resources, your RAN, and that sounded very efficient, and it is. Unfortunately, it creates a whole set of other problems because the reality is there are latency and jitter issues associated with the transport of RF at longer distances across potentially poor optical network connections and whatnot. So the opinion that we have is it actually complicates things quite a bit, especially when you're talking about sharing. And the reason is because if you're talking about multiple network operators and you're talking about multiple bands, the amount of dedicated fibers required to accomplish that on a particular project could become quite high. So, in some cities, a particular pole could, if it's specifically if it's colo, could end up seeing quite a few strands of fiber. Some in the order of dozens of fibers, right? And actually even more than that, depending on how many operators and what happens in the future on services. So right now, those would be all dedicated fibers. That's currently the way the network operators like it, though. They've been accustomed to using dedicated dark fibers, and they're from an access network perspective, and they're just now coming into the idea that, oh, I could potentially use wavelengths to provide that service to the location, but it just creates a whole other set of problems. And essentially, let's remember what CIPRI and CRAN is. It's the digitization of the RF signal to get it to all these remote locations. The reality is there's other ways, like even Lance mentioned, there's lots of other ways to get even though it's all digital, there's lots of other ways to packetize and get that signal from one location to multiple locations out of the network, whether it's in building or outdoor. So it absolutely does create other complications. The thing that it does solve, though, is it does allow you to remove the base stations or the traditional base stations from the equation, which are of course expensive, heavy, difficult to deploy, and can't go deploy very quickly, versus a much more compact radio access network equipment like the BBUs.
So what I'm hearing you say is that this partitioning is simple and simplified when you have a single operator with one network. There's one RRU, one BB, and one strand of fiber. But when we go to MNO, multi-carrier deployments, then the radios are not being shared unless you make them share the radios. And in order to share the radios, they have to be in the same frequency bands, right, or close enough, right?
Well, it's even more than that, Haig. So what happens if one operator is ALU and one operator is Ericsson equipment? They're not going to share BBUs and they're not going to share RRUs, right? So from a RAN perspective, it's very problematic.
So neutral host multi-operator virtualization will be impeded by the fact that different operators may have different vendors. That's what you're saying.
Today.
So are those challenges unsurmountable, or what solutions do you propose?
The solution I propose is that eventually that proprietary BBU cores will ultimately be virtualized in software. Once that happens and there's standards created amongst that on that interface, The reality is you potentially could have standardized interfaces that could go into the front end of a DAS, it could go into other people's radio heads or any type of device like that. And at that point, you could then start sharing, you can start combining things, doing things. But as long as it's proprietary that way, it's really very, very difficult to create a multi-operator situation on a single.
So Femi, with Fujitsu having experience in Japan, I'm sure you guys participate in the CloudRan deployment there.
Yep.
Do you have any success stories where a CRAN implementation has been deployed and shared by different operators?
Oh.
Are you aware of any? Yeah, deployed, I'm aware of,
Okay.
independently by KDDI and by SoftBank.
Right.
Are you aware of any that are shared?
Not as of today.
Not yet.
Yeah.
Anywhere in the world?
I don't believe there is anywhere in the world where that is happening. I mean, we have technologies that we're building that will enhance that will make that to happen. Just like he's saying, our concept is by the time you really come into the virtual space where the BBU is now virtualized, conceptually you can actually spawn virtual BBUs that will be dedicated to each carrier in the same box, and that's how you will get the sharing. But we're still far from...
But is it more important to share the BBU or is it more important to share the RRU? To me, the RRU has installation aspects, antenna aspects.
That's actually the easy part.
That's the easy part?
That's the easy part. What we believe is that you can have different radios that are different frequencies. Once you come back into the central location, you are just dealing with digital samples. They don't have to be RF. So you can have multiple radio points that are coming back into that central port. And if you have virtual BBUs that are dedicated to each operator, now you are home free. So it's not the radio that's a problem. It's actually the BBU. And as he's explaining today, they don't want to play nice. We're pushing them towards standardization, open interface, so that all of that can be shared successfully. But I don't believe there's any part in the world where it's being deployed today. I could be wrong, but I don't believe that.
Okay. So, Ray, I'm going to ask you this question and then see if Lance wants to answer it as well. Opportunities and challenges in terms of bringing all these CIPRI traffic from CRANs and the need for switching them so that as you grow, as you know, in year one we deploy a network, in year two we have to add additional ones and we have to reconfigure it so that adjacent sectors end up being neighbors on the BBU side as well, so you can do noise cancellation and the comp and all those ICIC protocols. What have you seen in terms of developments for CIPRI switching that would enable this?
Hank, if you could pull the microphone closer to him, we're recording it, so I want to make sure we get you on the tape.
Sure.
So the closer the better.
Sure. So I think this is probably a better question for Lance when talking about CIPRI switching. We're fundamentally focused on the delivery of that light and whatever the protocol is. So
Lance, you want to take that one?
Yeah, let me go back to the interface. We specifically created an open API application interface that allows anybody's BBU. We do not need to know the CIPRI proprietary information of that particular OEM's BBU. And we provide them the information that interfaces because they are transporting via CIPRI, and we actually can transport through the system via CIPRI. We can deliver that content in the IP packet they deliver to us without ever knowing their CIPRI proprietary information. So I think there's a fundamental architecture difference of what we have done. We have not tested that with any of the OEMs. We welcome that opportunity. We have presented it to several. But as a small organization, and as we start to get more traction, I think people will start to realize that we actually do have the ability to put an ALU BBU into our interface, or an Ericsson ALU or Ericsson BBU into our interface, and transport that out and drop it off at their remotes or at our remotes. So we do have that capability. As far as CIPRI and switching, as the RAM becomes virtualized and the content is delivered via fiber to the curb or to the building, we do believe that there's going to be the need for digital switches in the building. And from there, it will be transported or out via fiber to the remote. So really, the only thing that resides in the buildings is an integrated remote with an antenna, or the antenna and all the elements. You know, there's conversations that we're having to integrate the antenna in with all the other active elements that come as part of the remote. So I believe that was your question, but we certainly recognize that there's going to be national telecom centers, you know, regional telecom centers, local telecom centers, where all of this content will then be distributed out. And again, because of the IP packet nature of our architecture, we can deliver that content anywhere on demand via CIPRI, via whatever protocol they decide. CIPRI might not be the most efficient means of delivering this content, so there's obviously some debate there. One thing, when you talk about the challenges of connectivity, is the CapEx and OpEx challenges. With a fiber network, I think one thing that will happen is they'll start to standardize more on fiber where fiber is available. That'll eliminate some of the complexity of the front haul and the back haul. It's not going to be the answer to everything, but if they can get to that point, we believe the complexity will be reduced. It will also commoditize the digital switches because it will be required in the network. But there's other means of delivering this content also. We have effectively demonstrated delivering over current GPON networks. We have an active system now in one of the major operators where we're delivering their content services via GPON. And we also believe the operators, and again, this is looking at OpEx, being able to operate on existing systems rather than creating new, pulling new fiber into the building. If you can use the existing PON system that's there, you know, there's 10 GPON and 100 GPON that we believe that they're also looking at. So we currently have a live trial going, working on GPON.
So in that case, GPON is used to connect RRHs to BBUs, or what is GPON used for? So
it's used as the infrastructure out to the remote, so you can basically bring the content into a 1x64 splitter, and you can actually split that transport in many different directions throughout the building. So it leverages the existing infrastructure inside the building.
So, I mean, I keep hearing the word fiber, 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 and I don't want to leave it that way, because there are places where fiber do not exist today, or to the operator it may be very, very expensive. There are other methods as well where you use either E-band radios or microwave radios. One of the reasons why many deployers of the network shy away from that is that with microwave, you may not be able to meet the specifications of CIPRI. But we have great solutions where E-band radios will still meet that specification of CIPRI latency and be able to backhaul or fronthaul your remote radio samples all the way back to.
Is this a product that Fujitsu has?
Oh yeah, definitely.
Does it support a single CIPRI interface, or does it also support multi-operator deployments where you have four? Single. So if you have 4 operators with one network each, you need to have 4 of those.
You can.
E-band.
And in the case where they do play nice, you can aggregate the content from the front together and bring it back to the core.
So,
Can I just add?
yeah, Ken, go ahead.
You know, regarding all that, this is really related to the first question that I answered, and that is this. We talk a lot about fronthaul, a lot about CIPRI. Specifically for in-building applications and some ODAS that are connected to large campuses and whatnot. The reality is that the fronthaul CIPRI approach isn't necessarily the best approach for all these applications. And the reason is because of the resources required to get it there. This kind of reflects off of what Lance was saying in his first question. The reality is CIPRI is a RF to digital conversion, and there's other ways to do that conversion and to get those signals, where they need to go. There's also solutions like what Solid and Fujitsu make with regard to WDM that allow you to take an extreme amount of capacity from point A to B via WDM solutions in order to get those sectors and those radios from point A to B. For example, a typical CIPRI stream is transferring one band and one radio to wherever you're trying to go, whereas a digitized RF can do a dozen bands and potentially even sectors, and if you use WDM, can do dozens and dozens of sectors and bands. You just can't do that with the fronthaul protocols. And remember, CIPRI is just a protocol, whether it's SONET, Ethernet, or whatever, right? There's just different methods to protocol packetize that architecture. So there's many ways to do it depending on the requirements. For example, there's nothing wrong with 70% of the buildings in the United States are, enterprise requirements are not being covered because of the signal source issues. There's nothing wrong with potentially having baseband generating equipment. You could call it small cell, you could call it Bs, baseband generating equipment on premise and delivering Ethernet capacity. Ethernet's connectivity to it by the network operator. So I'd like to point that out because that is a complete other approach that in a world where we're really small cell oriented and fronthaul and CRAN, we're losing sight of what we're trying to do, which is get that capacity to the location and then solve the problem of physics, which is getting the RF to the handset, which is the physics equation.
Thank you, Ken. My next question is for Ray. Ray, can you share with us Zenfi's innovative all-access network approach to deploying urban small cells and CloudRan technologies?
Sure. So, one thing I want to back up and point out is, we talked about sharing of resources, and in our business, as an underlying network provider, everything works because of sharing. We're much like the tower environment where we have to build very costly infrastructure, conduits and fiber systems, and connect to places that it doesn't make sense for there to be a lot of parallel paths and a lot of parallel connections. So, we're in the business of sharing network infrastructure, and the element that we share at typically is a dark fiber strand, although we can break it down to wavelengths and go further up the stack. But our fundamental element is fiber within a cable that may have anywhere up to 864, and now with some of the newer cables, 1728 fibers in a single cable sheath. So that's an important piece of what we do. We believe, from Zenfi's perspective, in a dense urban environment like New York, we think there's a fundamental architectural problem that needs to be solved to support the densification of mobile networks. The answer to the problem seems to be certainly spectral splitting and creating cells any and everywhere. And you take a city like New York, where we're building out our first and a very large-scale network. There's 3,300 intersections in New York, which we believe every one of those intersections needs cell sites effectively or antennas. Every one of those needs to be backhauled, fronthauled back to aggregation POPs, and that amount of connectivity. If you've been in the fiber business, or you understand how the interconnections are made from antennas off to a cable on a fiber network, it's just impractical to expect that at every single intersection up Fifth Avenue you can break out for another antenna very easily, cost effectively, and there may not even be the space or capacity to allow for this. So our decision when we got back into the fiber business after having sold a company that did a lot of enterprise and carrier wholesale in the past was to focus on solving this fiber to the antenna problem and building a network of networks, a network that included fronthaul, backhaul, and distributed co-location. The fronthaul network, the differentiator is it has the capacity and the capability to be fragmented, to put antennas literally anywhere that the mobile operator needs it, whether it's on a light pole, the 50th story of a building, in a subway tunnel, or just a facade of a building. Anywhere that fiber needs to terminate, we'll get it there. But the traditional networks that have been built for years, and mostly in support of large enterprise and supporting the centralized application of bringing users back to data centers, just aren't suitable for this type of fragmentation and the capacity requirements that fiber to the antenna is going to need. And you take a city like, again, New York, Manhattan has 2,000 cell sites today, approximately. The estimates that we hear from the mobile operators is that we probably need 100,000 antenna locations just in Manhattan alone. And so today's networks aren't built to do that. So again, we've come in with a new approach to allow fragmentation. We could drop fiber on every block throughout New York, and we can get it back to distributed colos and then ultimately back to central switching environments. So that's our differentiator.
So Ray, when you say we drop fiber, do you mean you already have dropped fiber, or when it's needed you will install fiber in the city?
Yeah, so we started building our network last September. So we have a couple 100,000 feet of cable deployed specifically in Manhattan, and we're building out a fairly substantial infrastructure. We expect to have, in the next few years, a couple million feet deployed with access supporting nearly every single intersection in Manhattan initially, and distributed co-location facilities throughout the city to support this front-haul aggregation. And one thing that wasn't discussed at length is, the CIPRI protocol, as Ken said, is inefficient, and one of the challenges of deploying CIPRI today is, you need close proximity of the remote radio head to the BBU. There's a latency requirement of being approximately 250 microseconds round trip. That means you're 20 kilometers or so, a little over 20 kilometers you have to work with between your remote radio head and your base station hotel. So that dictates the need for neighborhood networks with neighborhood colos that ultimately connect together. So if that problem's solved by Dolly and others where we can eliminate that, then we can change our business plan.
So for years we heard that deploying fiber is cost prohibitive. How are you deploying millions of feet of fiber or thousands of miles, let's say,
yeah.
And who's paying for it with what, $1,000 per meter? Is that the benchmark in New York City?
Yeah,
how much does it cost, and who's paying for this?
So one of the interesting characteristics of New York City specifically is it has a pervasive conduit system, in Manhattan, and certainly a big conduit system in the boroughs and lots of poles, right? So, the more appropriate range of price in existing conduit is, 25, 30, 40, maybe $50 a foot to deploy. In worst case scenarios, when you're not trenching and digging. If you end up digging, you could pay $100 a foot to $300 a foot.
And is this fiber primarily being used for cellular base stations, or is it also being used for Wi-Fi?
Yeah, so our network is, we're in the fiber to the curb, fiber to the antenna business. So we don't care, what actually connects to it. What we do care about is what are the bandwidth, the latency specifications, the optical power levels that are required, and other sensitivities, and we'll design, the connectivity around the customer requirement.
So, Lance, tell us about dynamic capacity allocation, and how does Dolly Wireless use this infrastructure to deliver dynamic capacity?
Well, fundamentally, Dolly's patented digital technology using our own proprietary CIPRI Plus, if you will, to transport signals to the remotes. Dolly already has a solution compatible, obviously, with CIPRI packet data transport. We see this evolving network of evolution direct to a flat IP network. As we mentioned earlier, the open API that the BBU can plug into our interface, fully module, that allows for the CIPRI to remain proprietary. And then what happens is that the remotes in our system all have an assigned IP address. So literally all of the packets are given assignments where to be delivered to each of these remotes. So you're looking at an IP DAS, basically network, DAS network. By automating the process, we can dynamically change those packets. We can move those packets of data around the network to allocate more capacity in different sectors as required. We can do this via timestamp. It's really a simple script written into our patented software. As these systems migrate away from being hardware-centric, that's really one of the focuses that Dolly has, is helping the operators become more software configurable, software defined. And this is just an element of how the spectrum efficiencies will be used. You still have the E911 challenges in the US. We demonstrated this dynamic capacity allocation through a system integrator in Singapore, NCS. They're part of the Syntel group. So there was a live trial that was done in probably the last 90 days where we demonstrated the capabilities of moving capacity. We can literally move, whether it's send an individual packet of data, whether it's a carrier that we can move throughout, for capacity purposes, band or even subband. We can literally take that information and move it throughout the system to allocate the capacity, again, where it's needed and when it's needed.
So this is essentially adjusting for people moving around and a given space having different needs at different times and places, right?
Correct.
That's the challenge for me.
Yes. Yeah, the other challenges that we've had with making this commercially available, again, is, and Ken, we were on another panel, mentioned E911, being able to do E911 horizontally and triangulate the neighbor list is hard enough. When you move that around and disrupt that neighbor list, it's difficult to do. And then as you get into the MIMO or the 5G, where you're going to be able to do E911 triangulation vertically, it does present some challenges, but our system does have the capability of taking those packets and moving them around the system based off where capacity is needed.
Thank you. Are there any questions from the audience? Please raise your hand. Yeah, go ahead.
Lance, I'm still trying to get my head around this. When you say moving the packet around the network, it sounds like, are you routing the traffic to where there's radio resources that can handle that data?
Yeah, so if we have remotes throughout this building, and as everybody migrates from the convention center into the casino, we can literally take the capacity of the remotes covering the convention center that are now not efficiently operating at 80 or 100%, and where the system would require more capacity, we can send it over via capacity allocation, send it to the other remotes already installed in the system. Can I take it from this building and send it across town? Not necessarily, but within that same system, I can move the capacity around to the remotes that are installed in the building. That's what we demonstrate.
Any other questions? Yeah, go ahead.
Relative to the CloudRan, do you see any challenges now? You talk about getting it into a standard virtualized baseband unit, but right now the CIPRI interface is creating problems relative to speeds and getting the data to the remote radio data. And so now you have people actually coming up with these hybrid basebands where they're splitting it. What kind of challenges does that present?
Femi, you want to take that?
Few challenges. First, as we move towards 5G, we're talking about much more higher data rates coming to or going to the remote. So CIPRI is going to get flooded out. The 10G is going to be done. That will not even be sufficient. And so there are a few things that we're trying to do now. One is split the baseband to have remote radio units instead of having remote radio heads, where you move more functionality towards the radio. The other one is to actually now look at what is the transport that will be able to support this, if it's not CIPRI. Very active now with IEEE doing what we are calling pseudo radio over Ethernet, for example, but it's not crystallized yet because at that point, since we have split some functionalities between the baseband and the remote radio, it's not IQ samples that we're sending. What are we sending? We don't know yet. What is the interface? Those are the challenges that we're still facing. But the good news is we can reuse existing Ethernet capabilities that we have. Ethernet support 100G, 400G. That would be very useful. But we're still working through, what is that interface? Definitely Ethernet, for sure. But where is that split? We're still working through that as well. Because once you split, you need to worry about what is the delay now? What is the latency? Have I affected my jitter? So all of those things we are working through. But I can tell you 100% is going to be Ethernet based.
So although there are many challenges, as you heard, in RAN virtualization, it appears that the benefits of sharing the radio and virtualizing and sharing the RAN, and also, as Ken mentioned, with the right approach, sharing the fiber infrastructure that connects it, override all those challenges. And this week we saw what may be an initial salvo where an established DAS vendor, CommScope, announced the acquisition of a CloudRan company called Airvana, which sort of signaled the convergence of the CloudRan market together with the DAS market. So my question to the panelists, and maybe starting from Ken, do you see on the path for this conversion, do you see a greater level of convergence where the DAS vendors who supply the plumbing and the radios converge together with the RAN vendors at some point? Do you see Ericsson acquiring CommScope, let's say, or a RAN vendor acquiring Solid, where you provide that end-to-end solution? Is that where we're moving?
I see a whole new breed of vendors popping up. Companies like Solid are going to be migrating, vertically and broad, and laterally in terms of technology. But I see a whole new array of vendors as things open up and become more open source. I see a lot of new vendors coming up that are more software based in terms of the network. I see that you heard me say earlier regarding what's wrong with baseband at the building. There's nothing wrong with it. I see that whole architecture opening up. I see it in two phases. Phase one is really it's going to take a while for the virtual RAN to occur, right? Before you have a cloud-based RAN, that's going to take a while, and it's also going to take time for those standards to occur to the point where it's not going to be all proprietary. While it's proprietary, what we're going to see is things like CIPRI potentially open up. We're going to see other standards pop up that will allow different vendors to be able to provide solutions for that, to lower the cost, to come up with more efficient protocols that can subscribe to that open standard. And so I think you're going to see the ecosystem of vendors in this space become much more diverse. And I think that the bigger ones are going to see that there's going to be a lot of new players, because it's kind of like the computer business, right? And the network business. As soon as you open standards, it becomes available to a lot of other creative people, a lot of other creative companies to come up with some very unique, efficient solutions that break the kind of the normal of this is the way it's done nowadays. You have to follow this and do this. Well, there won't be any normal anymore, because the reality is the carriers, everyone's pushing towards that efficiency. And so it's going to be a pretty drastic changes.
Femi, do you agree?
Yes, and much more as well. I think in the immediate past, one of the things that unfortunately has happened in the industry is the comparison between the capability of small cell and the capability of DAS. But the actual reality is that you need both. And so what you're finding is in the indoor space, you need small cells to feed DAS. DAS does a better job in where you have the right configuration. And so the convergence of the two is actually now solving the problem in a unique and fundamental way, because you need both. So in addition to what Ken is saying, I think the coming together of CommScope and Nirvana has just actually realized that we don't have to fight each other, we can play nice as we go forward.
Very good. Thank you very much. Lance, you want to add any closing comments?
No, I would just add that I think it's obviously moving from a hardware-centric business to a software configurable or defined business. How we get there and the connectivity in between, it's really a part of the toolkits that will be designed and developed, and hopefully it will become standardized and not proprietary. So that's the only thing I would add.
And all of this virtualization is going to put higher and higher demand on Zenfi's fiber network. You agree, Ray?
I certainly do.
Excellent. Well, thank you so much for being on this panel, and we'll see you soon on another panel.